Welcome to today's lecture. Today I will discuss about signals and the classification of signals. So what is a signal? Signal is nothing but anything that bears information can be considered as a signal. Anything that bears information, that is called a signal. For example, speech, music, all these things are signals only. That means signal is nothing but a quantity which bears information. That is what is called a signal. Mathematically, signals can be modeled as a function of one or more independent variable. Okay, signals can be normally mathematically modeled as a function of one or more independent variable. Okay, so one example, independent variables are used to represent the signals are time, frequency, or spatial coordinates. So a signal is actually a function of one or more independent variable, and normally while drawing a signal we need two quantity, one is amplitude, one is time. That means on the basis of time, if you are considering it is a time domain signal, if you are drawing the signal spectra with respect to frequency, then it is a frequency domain. If the signal is considered in a spatial domain like electromagnetic signals, then we consider spatial coordinates. So each signal is mathematically modeled as function of one or more independent variable. This independent variable can be time, frequency, or spatial coordinates. Okay. So in this section, here in this chapter, we will discuss the independent variable as time. Here we consider signal with respect to time. What happens to the amplitude as time increases? That's we discussed in this chapter. So first is signals mainly classified into two. We can classify into two. One is analog and another one is digital. These are the two different classification of signals. Okay. First one is continuous time or analog signal. Continuous time or analog signal. So look at this diagram. This is analog signal. This is continuous in time. This is discretized in time. What is the difference between these two? This is an analog signal. What is analog signal? Analog signal is nothing but its amplitude is continuously varying. Okay. Digital means we know that what is digital. 1 0 0 1 2 voltage levels are there. We know 1 0 1s and zeros are the two digits. For 1 corresponding we have plus 5 volt. For 0 corresponding we have 0 volt. This is actually digital, but here it is analog. Analog means like all our signals are analog. All our physical signals are analog. Like it's a continuously varying with respect to time. So it is called a continuous in time. That means the time is continuous. Okay, see, for this, for a particular voltage, consider a particular time, consider a particular voltage, it is having an amplitude. Again, consider a particular time, consider a particular voltage and time, again it is having an amplitude. Like that, it is continuously varying. For each and every time, it is having an amplitude. Okay, for example, here I am taking from 1 second to 5 seconds. Within that range I am taking values. For each and every minute values it is having amplitude, and the amplitude is continuous. That's why continuous in time. Okay, this is another signal that is discrete in time. This is actually an analog signal, but it's discrete in time. What is analog? Analog means it is a continuously varying signal. Amplitude is continuously varying. Discretized in time means this is discrete. This is also an analog signal, but discrete in time. Look at here. For 0 amplitude. For 1 second it is having a discrete amplitude. For another time a corresponding amplitude. For another time 1 amplitude. That means here I am sampling this signal. Here I am sampling. This is my continuous signal. I am sampling this signal. And for a particular time, what is the amplitude? That is the discrete in time. That means time is discretized, but amplitude is continuous. Look at here. Still here amplitude is varying. Okay, for this amplitude is 0. This amplitude is high. This is again amplitude is very high. This is the maximum amplitude, then amplitude decreases like that it is going. So here amplitude is continuous, but time wise it is discretized. For example, for 1 second what is the amplitude, for 2 seconds what is the amplitude, for 3 seconds what is the amplitude. So time is discretized, that means time is specific, time is specifically defined. For particular second what is the amplitude, that is discretized in time, that means time is discretized but amplitude is continuous. That is the analog differential classification. Analog signal, one is continuous in time, one is discrete in time. Now what is digital? Look at here, digital. Here this dotted line is actually continuous, but here we are discussing about digital, so I quantized it into different values. So this is the digital. For this time, this 0 is the amplitude. For this time, another amplitude. For this much time, another amplitude. For this much time, another amplitude. Like that it is varying. Okay. So digital means it is having two levels, either 1 or 0, like that it is going. So the amplitude is fixed for a particular time. Okay, for this time amplitude is fixed. For this time, for example, from here to here, amplitude is fixed. From here to here amplitude is fixed. Okay, this is digital. So this I am taking different amplitude levels, and that for that amplitude level I am quantizing the signal. Okay, so similarly I am drawing this its discretized form. For this amplitude I have one quantity, for this amplitude I have one quantity, for this amplitude I can take here and I can draw a line like this. Like that I can complete this. So this is the discretized form of a digital signal. Okay. So one is continuous in time or analog signal. So this is analog signal, that is continuous in time. Continuous in time and continuous in amplitude is called analog signal, that is continuous in time, continuous in amplitude. This is amplitude axis, this is time axis. So as time increases, amplitude is also varying. So amplitude is continuous with respect to time. But here amplitude is continuous but time is discrete. So amplitude can take any value in the continuous range from minus infinity to plus infinite. So this amplitude can have values from minus infinity to plus infinity. Next is discrete time. Discretized in time and continuous in amplitude. We know discrete time means time is discretized but amplitude is continuous. Most discrete signals are arise from sampling of continuous time signal. Continuous time signal, if you sample, that means if you tap particular power levels, then you will get a continuous discrete time signal. Next is digital signal. Discretized in time, quantized in amplitude, that is amplitude of a signal can take only value from a finite set of numbers, that is digital signal. See, this is digital signal. This amplitude can take certain range of values only, but here amplitude can take any value. But here, look at here, for this range the amplitude is fixed. For this range amplitude is fixed. This range amplitude is fixed. That means amplitude can take a certain range of values only. That is digital signal. So an amplitude of signal can take only value from a finite set of numbers. That's about digital signal. Next is different types of signals. First is different signal. First one is unit step function. Okay, this is called step function. Normally this step function is represented by u of t. Step function is represented by u of t. Okay. So all the signals discussed in this chapter, the time we are taking time as the reference. So independent quantity is time here. As time varying, what happens to the amplitude of the signal? That is the thing which we discussed. In signals, first one is unit step function. See, this is the diagram for unit step function u of t. This is the time, this is the amplitude axis, time axis. What is this? As the time, by looking itself we can understand, as the time increases, amplitude is constant and the amplitude is nothing but 1 volt. That means amplitude is 1. Here from 0 it is varying to, it is varying means it is continuously varying to an infinite value. For all the values amplitude is constant. Okay, so that is the step function. How can we define step function? U of t is equal to 1 for t greater than 0. See, for this is 0 value, this is 0, greater than 0 amplitude is 1. What about less than 0? Amplitude is 0. There is no amplitude here, so less than 0, as time less than 0 amplitude is 0, as time less than 0 amplitude is 0, as time greater than 0 amplitude is 1. What about at t equal to 0? At time t is equal to 0, it is varying from 0 to 1, it is varying. Okay, for time t is equal to 0, it is 0 to 1, it is varying. That means a discontinuous amplitude. Okay, it is not 0, it is not 1, it is continuously varying. So we take u of 0 as 1 by 2. U of 0 as 1 by 2 means at time u of t is the representation of signal. What happens when time t is equal to 0? When time t is equal to 0, we represent as u of 0 is nothing but 1 by 2. That means at time t is equal to 0, we are taking the average of these 2 points. This is 0, this is 1, 0 plus 1, 1 by 2 average. That means 1 by 2. So at time t is equal to 0, amplitude of this signal is 1 by 2 on an average we are taking. So that is about step function. This kind of signals you can see, for example, a battery is there and battery is connected to a switch. When the switch is closed, the battery is, for example, 5 volt DC. The battery is giving a 5 volt DC and it is connected to a circuit. So after battery you have a switch. When the switch is on, you will get a 5 volt. When the switch is off, the supply voltage is 0. When the switch is off means there is no output there. For example, like this, you have a 5 volt DC and it is connected to a switch and then the remaining circuit. Okay, so this circuit a circuit is here. Just assume a circuit is here, but here you need a 5 volt DC. For the supply you have to close the switch. Okay, at time t equal to 1 second you are closing the switch, then you will get a DC supply. So we can say from time t is equal to 1 second, we switch the switch is closed, so we will get a 5 volt DC. That means how can we, this is for 1 second, for example here I am taking 1 second. From 1 second I am getting 5 volt, and for t is equal to 10 second also it is closed. That means for continuously it is closed. That means it is continuously a 5 volt. Whenever the switch is open, the voltage, we won't get any 5 volt DC. That means at that time it is 0. Like that it is going. As and when the switch is closed, at that time continuously you are getting a 5 volt. That is a step signal. Next is rectangular or gate pulse. See, this is the rectangular function. A function is signal is represented by a rect t by 2a. This is the representation. It is varying from minus a to a and it is a constant amplitude, capital A, varies with the time. So it is at a confined, that means for a certain range of values, for a certain range of time it is having an amplitude. After that there is no amplitude. That is rectangular or gate pulse. Next is signum function. Signum function is represented by Sgn of t. This is the representation of signum function. This is the representation of signum function. As time increases, what happens to the amplitude? Okay. Amplitude is signum function is Sgn of t. For t greater than 0, we have an amplitude. For t less than 0, we have another amplitude. So that's why it is written like this. Signum function of t Amplitude is 1 for t greater than 0. Amplitude is 0 for t equal to 0. Amplitude is 1 for t greater than 0. Look at here, as t greater than 0, amplitude is 1. What happens t less than 0? As t less than 0, amplitude is minus 1. T less than 0, amplitude is minus 1. What happens at t is equal to 0? Normally we are taking the average of these two. At t equal to 0, we have plus 1 and minus 1. Take the average. Okay. So we are taking the average here. How? These two values are added. 1 plus 1, 1 plus minus 1 by 2. That means 0. Average is 0. Okay. So at t equal to 0, it is actually discontinuous. That means it is varying from minus 1 to plus 1 at t equal to 0. This is the 0 value. This is the time axis at time. This is the 0.0 second at time t equal to 0. The amplitude is continuously varying from minus 1 to plus 1. So the average is 1 plus amplitude, just you check the average of these two amplitude. 1 plus minus 1 by 2 means 0 by 2, 0. So amplitude is 0. That's why time t equal to 0, amplitude is 0. Next is a ramp function. A ramp function is represented by r of t. This is the signal representation, and here we can write it as r of t. So as time increases, amplitude is varying. At time, look at here, at time t equal to 0, amplitude is 0. That's the important here. At time t equal to 0, amplitude is 0. As time increases, amplitude is also increases. Okay. So we represent it as t. So for example, for 1 second, it is having amplitude of 1 volt. For 2 seconds, it is having another amplitude of 2 volt. Like that it is going. So what happens? How can we represent this? R of t is equal to t for t greater than or equal to 0. Of t greater than 0. That means when t greater than 0, what is the amplitude? T only. What is the amplitude? T. For 1 second, 1 volt. 2 second, 2 volt. Like that, the amplitude is increasing. Okay. So R of t is equal to t for t greater than 0. That means as time increases greater than 0, amplitude is also increasing. What happens at t equal to 0? Amplitude is 0. Next is sampling function. Sampling function is represented by Sn of x, that is sin x by x, and this is the representation of sampling function. Another signal representation is unit impulse or Dirac delta function. This is one of the most important signal, Dirac delta function or unit impulse function represented by del of t. Many physical phenomena such as point source, point charge, voltage source acting on a short line can be modeled with this function. This is the representation of Dirac delta function. It is represented by del of t. This is the signal representation. Look at here, at time t, this is the time axis, this is amplitude. At time t is equal to 0, we have signal. Above 0, below 0, there is no signal. At time t is equal to 0, we have a signal del of t, and its amplitude is continuously varying. That means it is going upwards, and there is no finite value. It is infinitely going. Okay. So this is the property. Del of 0. We know the del of t. When time t is equal to 0, we can represent it as del of 0. Del of 0 is infinite. That means at time t is equal to 0, what is del of t? What is its amplitude? Del of t means its amplitude. At time t equal to 0, its amplitude is very high. Infinitely, it is continuously going upwards. Okay. So del of t equal to 0, del of 0 at time. That means at time t is equal to 0, what is del of t? T equal to 0 means del of 0. Del of 0 equal to infinite. That means which at time t is equal to 0, this point. At this point, the amplitude is infinite. That means it is going upwards. So del of 0 is infinite. What happens after del of t at time t not equal to 0? T not equal to 0 means this section and this section. On above and below 0, amplitude is 0. That's why del of t is 0 for t not equal to 0. At t equal to 0, amplitude is infinite. At t not equal to 0, amplitude is 0. That means this signal exists only for time t equal to 0. For all other values of time, amplitude is 0. But at time t equal to 0, amplitude is infinite. minus infinity to plus infinity del of t dt. We are integrating minus over plus infinity. This signal will get a 1 only. Okay. Now another property, del of minus t is nothing but del of t. That means del of minus t means we are shifting this, still we get to del of t only. Del of minus t means we are just taking the mirror mesh. For example, it is like this. For 0, this is time t, this is minus t. You take negative of this, you take negative of this become minus, this become plus, and it will be changing like this, plus t like this, minus t like this, 0 here. That means the same signal only. That's why it is called del of minus t equal to del of t. This another signal is exponential signal. See, exponential signal can be two types: exponentially decreasing and exponentially increasing signal. E raised to minus at as a less than 0, that means exponentially decreasing. So this is exponentially decreasing, this is exponentially increasing. E raised to at for a greater than 0, that means a less than 0 means minus a only. Okay, that's why it is exponentially decreasing. At time t equal to 0, what is the amplitude? At time t is equal to 0, you have to put t equal to 0 here. That means e raised to 0, e raised to 0 is 1 only, amplitude is 1. As time tends to infinity, what happens? This is actually e raised to minus at. Okay, a less than 0 means a minus sign is here. Okay, so e raised to minus at, this can be represented as 1 by e raised to at, 1 by e raised to at. Okay, e raised to minus at means a less than 0, that's why e raised to minus at is can be represented as 1 by e raised to at. As time tends to infinity means we can put t equal to infinite. E raised to infinity means 1 by e raised to infinity, that is 1 by e raised to infinity. 1 by e raised to infinity means 1 by infinity. 1 by infinity means 0. So that means as time tends to infinity, its amplitude is approaching to 0. Okay, that is exponential signal, exponentially decreasing, this is exponentially increasing. As time tends to infinite, amplitude is increasing. This is another representation. That all these things which we discussed are continuous. This is discrete signal, unit step sequence in discrete. That means for discretized in time, this is time axis, and time axis is discretized 0, 1, 2, 3. For 0 second, what is the amplitude? For 1 second, what is the amplitude? 2 second, what is the amplitude? 3 second, what is the amplitude? That means amplitude is continuous, but time is discretized. So u of n is equal to 1 for n greater than 0. Look at here. For from 0 to it is extra. That means from 0 to a high value, from 0 to as n. This is n. This is normally represented as n. Instead of t, we are normally represented as n. As n greater than 0, amplitude is 1. This is n value. From n greater than from 0 to increasing, amplitude is 1. What happens for less than 0? Amplitude is 0. That means for n less than 0, amplitude is 0. This is the n axis. So that's about signal. Next we will discuss about classification of signals in the next lecture.